Here we are, Stats and Mechanics, Year 1, Chapter 10, Question 12. Okay, a particle P and Q of mass 2n and m respectively are attached to the end of a light, inextensible string which passes over a pulley. So we have a 2m here and an m here, and they are going over a pulley. Don't know why I've done it so small. Right, like that. Okay, and over pulley, they both hang at a distance of 2 meters above the ground. Okay, so from here to here is 2 meters. Lovely. And both horizontal, the system is released from rest. Excellent. All right. So find the magnitude of the acceleration of the system. Right then, well, let's consider each part. Let's consider the left-hand side, the right-hand side. They were labeled up as P and Q. So I've got some masses on there. Let's change that into a force, because it's a force coming down, and I've also got the force of tension coming up. This one has a force of tension. This one has a mg coming down here of a force, and there is acceleration going on with this, the heavier weight on this side. So I've got an acceleration coming down here and an acceleration going up here. Okay, now with all of these things, always consider whether or not we have a positive or negative situation going on. So for the sake of it, I'm going to consider up to be positive and down to be negative. Okay, so working on which side was which, this is P, this is P, this is Q. So working on P, I'm going to set up F equals MA, and so my forces, I've got a tension force going up, minus a 2mg force going down, and that's equal to my mass, which is 2m, times my acceleration, which is a minus a. Okay, times a minus a. There we go, lovely. On my Q side, I'm also going to set up F equals ma. Okay, so with that, again, let's do all the red forces. I've got tension going up, okay, minus an mg coming down, and that's going to be equal to my mass of m times my acceleration, which is positive this time because it's going up. Okay, so just being very careful about my positives and negatives as I go down. So first things first, let's see. Everything is equal to, what am I looking for? I'm looking for acceleration. Okay, so acceleration. They look like they're all equal to tension. So if I put this here and I say, right, 2mg, moving it to the other side, minus 2ma, okay, and I do the same with this one, tension equals mg plus ma, then I can put these two tensions together and get 2mg minus 2ma is equal to mg plus ma, because the tension is the same on the string all the way around. Okay, trying to get all the A's together, aren't we? So I'll bring the 2ma over this side, and I will get 3ma. We'll bring in the minus 2ma, adding it to here gives me the 3. Okay, and we will bring the mg this way, so that becomes 2mg, take away mg, which is just mg, and of course mg divided by 3m is equal to a. Cancel out the m's, and g over 3 meters a second minus 2 is equal to a. Acceleration is a third of gravity. Okay, what next? Part B. find the speed of P as it hits the ground. Okay, which one was P? P is over here. Let's work out the speed of it as it hits the ground over here. So if we're talking about speed, we are probably talking about suvat. So I know my distance, they told us 2 meters. Okay, my initial speed was rest. My final speed, I do not know. My acceleration, I just worked out as g over 3, and I don't know my time. So suvat equations, where are they here? What do I want? Something with no time in it. So we can look at v squared equals u squared plus 2as. Okay, v squared is equal to 0 squared plus 2 times g over 3 times 2. Okay, and so v is equal to the square root of 4g over 3 meters a second. Okay. I wonder if they want that as a decimal. Did they want it as a decimal? Did they say anything in there? Quickly do a decimal because we are doing mechanics. Okay, so I should probably do a mechanics for the g over 3 as well. Okay, so 9.8 divided by 3 for that one should have been 3.266. So this one is 3.267 meters a second minus 2, and this one is the square root of 4 times 9.8 over 3. 14 root 15, something or another, 3.61. Okay, so 3.61 meters second minus 1. All right, good. Given that particle Q does not reach the pulley, find the greatest height that Q reaches above the ground. So, what is going on there? As it shoots up, this one comes down and hits the ground, okay, smack, and this one has shot up and has stopped, but it won't have stopped. It's going to bounce a little bit on the string and come back, okay, so just at that point it's going to come up and then it's going to go into free fall and come and stop, and we want to know what that greatest height is there. So let's think about that again for suvat. Okay, we don't know the distance. We do know the initial speed because the initial speed is at the point where this one has hit the ground. So it's got the same initial speed as what we just worked out, which is going to be root 4g over 3. That square root goes across everything. The final speed will be 0 because it will be at the top of the arc of flight, okay, and its acceleration is going to be minus 9.8. The only thing slowing it down at that point is going to be gravity, okay, and time we don't know. So again, we are looking for suvat, which has no time in it, so we can use the same equation as before, okay, and so we can use v squared equals u squared plus 2as. So 0 squared is equal to the square root of 4g over 3 squared plus 2 times minus 9.8 times s. All right. So we are going to have, let's bring that over there, 9.8 times 2 is 19.6. So 19.6 s is equal to 4g over 3. And so 4g 4 times 9.8 which is 39.2 divided by 3, which is 13 1/6 divided by 19.6. Okay, oh, 2/3. All right, S is equal to 2/3 meters. So what was the question? Find the greatest height of Q that reaches. Well, it started 2 meters up. It went another 2 meters up. That makes it 4. So greatest height is 2 plus 2 plus 2/3, 4 and 2/3 meters, because for the 2 meters that this one fell down to the base, this one went up 2 meters. So at this point now I've got 2 and 2, and then I've done a little bit of a lip there, which is the 2/3. So done. Next, then, state how you have used in your calculations the fact that the string is inextensible. Okay, the very small. Where are we? Okay, inextensible. I can never spell that word. String means we will have equal acceleration and equal tension on both sides of the pulley. Is it EY for pulley? Okay. Can't spell tension either. All right, it's an S, isn't it? All right, so that's part I, DI, and then if we do DII, what did that want to know? The fact that the pulley is smooth. A smooth, 2 O's. A smooth pulley means no friction in the system, so no resistance to the particle. Basically free to move, isn't it? Okay, I think that's everything for those ones. So that's that. Same tension string, acceleration, both masses equal. Okay, good.